This is my final year project implementation of cyclic coordinate descent, and this is one of the simpler algorithms. We update our positions here so we can check the distance from our end effector to our target. We just simply find that if it's within our epsilon or delta, we break and stop over iterating over the joints. And so the algorithm itself starts at the end effector, make sure to get to the end of the route. And so we find the next joint, or the previous joint, the one before the end effector, and we find distance here from the previous to the current. And then we find born to target, which is the current joint, with, in this case, the first iteration, be the distance from the end effector to the target. And we simply just do a rotation from the two, from the previous joint to the end effector, and from that point, and from the point between the born to target. And then we just add on the rotation, which is, multiplication is needed for quaternion addition and the rotations. And that's simply that. You can see that in action. So we see here, we're going to start with the end effector, and what's going to happen is it's going to take this joint here, which is the j+1 at the start, and the joint to the effector, and from this to this here. And so we will find this point as where, this direction is where we want to rotate this joint to, by finding two parts of the triangle, and then this. And so we'll just simply see this orientate to this line here, as we can see here. We've found the distance from this joint to the original position, from this original position to this target here, and we rotate this from this direction. Yeah, this is the one we find. We find this direction. And so once this becomes too much, we start rotating the next joint in the sequence. And so eventually we start rotating all of the joints. And this is a very efficient and useful algorithm, but it's not very realistic for MIBs, for emulating or simulating, limbs, because this takes the least energy. It finds the least required amount of energy to reach at the end effector to the position. So fabric maybe might arc over, and CCD simply finds the least amount of movement to get to the point by orientating this one to there. If it can reach it, it breaks. If it can't reach it, it tries to orientate this joint. If this can't reach it, so on and so forth, down the chain, as we can see here. This isn't the algorithm I mainly focused on during my project, as we can see here, just from looking at it we can see that it's not true to human movement. If we think of this as an arm and this is the hand, and if we tried to reach something, we wouldn't just bend our wrist down, we'd move our whole arm down. And same here, we wouldn't pull our wrist up and then down to reach it and move our elbow. We would move the whole arm maybe out towards the elbow joint using a pole. Maybe it'd reach out here and then come across. And you will see this in action, these things in action in the other videos.